Module 14, the respiratory system, the muscles and mechanics of ventilation. The first function of the respiratory system that I introduced is ventilation, which is bringing air into the lungs and letting it back out. As you probably can figure out, this process requires many muscles working together in a coordinated fashion for this to happen. First, if you pay attention to the words inspiration and expiration, you will be better able to mentally follow what's going on here. Inspiration has to do with taking air into the lungs, and expiration has to do with releasing air out of the body. There are 3 muscle groups involved. They include muscles of principal inspiration, muscles of forced inspiration, and muscles of forced expiration. Let's begin with the muscles of principal inspiration. When you're at rest, you use 2 sets of muscles, the diaphragm and the external intercostal muscles. To exhale at rest, there are no special muscles involved. You exhale as a result of the principal inspiration muscles relaxing. Now, if you want to take a deep breath, say for example to shout or exercise, you use the muscles of forced inspiration, which are the sternocleidomastoid muscles, the scalene muscles, and the pectoralis minor muscles, which are deep to the pectoralis major muscles. To consciously exhale, you use the abdominal muscles and internal intercostal muscles. These muscles form the muscle group of forced expiration. Now, the diaphragm is a sheet of muscle that fully relaxes when we exhale. In order to inhale, the diaphragm contracts, shortening in length and pulling downward. This pushes against the abdominal organs that are below it, thus increasing the size of the thoracic cavity in the chest. That vacuum created causes the lungs to expand, which causes air to move into them through the mouth or nasal cavity. As the diaphragm relaxes, it expands in length, moving more quickly upward as the organs in the abdomen help to push it upward. That makes the thoracic cavity smaller in size, thus pushing inward on the lungs. The air then moves out of the lungs and out of the mouth or nasal cavity. Though I was talking about principal inhalation, I was only going over the diaphragm's part in it. There are other muscles involved here too. During principal inhalation, the external intercostals contract to pull the ribs upward and outward. That also makes the thoracic cavity expand, thus making the lungs expand along with it. So we can say that muscles of inhalation work to increase the volume of the thoracic cavity. If you want to take a conscious breath or a large one, you need the muscles of forced inspiration. The sternocleidomastoid, pectoralis minor, and scalene muscles work to either pull the ribs or sternum upward or outward as they contract. That will make your thoracic cavity even bigger, so it can take in even more air. Now let's discuss expiration. At rest, you exhale as a result of the inspiratory muscles relaxing. In the example of the diaphragm relaxing, the abdominal organs just passively push against it, causing the size of the thoracic cavity to decrease. And if any other inhalation muscles relax, they will also decrease the volume of the thoracic cavity. All this works to push against the lungs, forcing air out of the body. If you want to do a forced expiration, then the thoracic cavity needs to be even smaller in size. This can occur when you contract your abdominal muscles. If you've ever laughed at a series of jokes or funny situations for a long time, you may feel a lot of tension in your abdomen afterwards, almost like you've spent some time doing a lot of sit-ups. Well, that's a result of the continual contracting of your abdominal muscles, which caused you to be able to forcefully exhale as you were laughing. You see, as the abdominal muscles contract, they push against the abdominal organs, which push up against the diaphragm, making the size of the thoracic cavity even smaller. The internal intercostal muscles also will pull the ribs inward to reduce its size. Therefore, we can say that normal expiration doesn't need any muscle contraction. It's just a result of the principal inspiratory muscles relaxing. But to push a greater amount of air out, you need the muscles of forced expiration, as well as the abdominal muscles and the internal intercostals. A lot of this should make sense to you because you can see the size of your chest cavity changing, especially if you are taking in a deep breath and then exhaling it. But why do the lungs take in air when the thoracic cavity expands? I alluded to this a bit earlier, but it has to do with Boyle's law. You see, Boyle's law states that at constant temperatures, the pressure of a gas increases with decreasing volume and decreases with increasing volume. Well, what does that mean? When your thoracic cavity decreases in size, there isn't as much volume available to the air in your lungs. That means that the pressure on that air, or the air pressure, increases. But the pressure outside your body, or atmospheric pressure, has remained the same. So the air inside your lungs is at a higher pressure than the air outside your body. And because the lungs have passageways to the outside via your mouth and nasal cavity, this means that the pressure difference will cause the air to move out of your lungs. For inspiration, as the diaphragm and intercostals contract, the thoracic cavity increases in size. This results in more volume for the air in the lungs, reducing the pressure in them. And the air pressure in the lungs then is less than the air pressure outside the body. Therefore, air will travel from that area of high pressure to the area inside the lungs, which is of lower pressure, and you take in air.